Good morning, good afternoon, good evening, ladies and gentlemen. It's a great pleasure to me to join this webinar and talk today about my favorite subject, mycotoxins and oxidative stress. I have been working with my antioxidants for the last 40 years, and about 20 years were also associated with mycotoxins. And today it's a good opportunity to share with you a recent finding. So usually I start with this slide just for you to understand that we are living in this dangerous world of free radicals, and those radicals are produced in nature, and we need some kind of umbrella, which we call antioxidant protection. We means our chicken, our pigs, our cows. Everybody needs this kind of umbrella. When we're talking about oxidative stress, we need to talk about free radicals. What are free radicals? They are activated molecules of oxygens, which actually can damage all types of biological molecules. And there are internal and external sources of free radicals in biological systems. And among internal sources, the mitochondria are considered to be major source of free radicals. Mitochondria, which are responsible for energy production, but energy production never been 100% efficient, and up to 3% of oxygen can escape from electron transport chain, and they become free radicals. There are also phagocyte cells in the body which are producing free radicals as a weapon to kill pathogens. For them, free radical production is a way to deal with pathogens. There are also some other processes associated with free radical production, as well as external sources of free radical production. And if you look at this slide, what I would like to show you here, that we have antioxidant defense system in the body, which is dealing with these reactive oxygen species or free radicals. And here you can also see mycotoxins as one major source, exogenous source of promotion of free radical production. And what also here important to mention that the physiological level of these free radicals are important for immune defense, for cell signaling, and many other functions in the body. However, the overproduction of free radicals, it's a damaging effect. And at this slide, I would like to underline once more that free radicals damage lipids, they damage DNA, they damage proteins. In fact, free radicals can damage all types of biological molecules. And what is important to remember that the oxidative stress as a result of this balance between antioxidant protection and free radical production is a major cause or major molecular mechanism or major stresses in poultry and animal production. And if you look at this slide, I just summarized main stresses in poultry production, including environmental stresses, technological stresses, nutritional stresses, internal stresses. And here, mycotoxins are considered to be major nutritional stresses which are causing a lot of problems. And you already participated in 3 previous meetings related to mycotoxins, where the negative consequences of mycotoxin contamination have been explained. So when we're talking about mycotoxins, we are talking about silent killers, invisible thieves, unavoidable contaminants, natural toxicants. All these names have been given to a group of fungal metabolites called mycotoxins, and their negative effect on animal production are incalculable. And if we look at this slide, this is the most recent one, 2020, which is summarized the research in the area of mycotoxins. You can see here that 22% of research related to aflatoxin, 18% to DON, 16% zearalenone, 15% ochratoxins, and combined mycotoxins studies are related to 20% of total research. And then here you can also see that the research related to mycotoxins in chicken in total comprise about 14% and pig 23%. So almost 40% of all research related to mycotoxins is associated with their effect on pigs and chicken. And as I mentioned already, that mycotoxins have detrimental effect on poultry, on pigs, on cows, on any farm animals. And the major mycotoxins of concerns include aflatoxin, ochratoxin, fumonisin, T2 and DON, and zearalenone. And today, the major point of the presentation is to consider more in detail molecular mechanisms of mycotoxin action with specific references to oxidative stress. And this paper came 2008, so it's already 13 years old. At that time, we suggested that actually mycotoxins are involved in creations of oxidative stress, and the inhibition of protein synthesis, DNA and RNA synthesis, and damages to DNA. This related to ochratoxin, T-toxin, aflatoxin, and other mycotoxins. Most of mycotoxins impose lipid peroxidation and structure membrane damages. Then we have also induction of the program cell death, which is called apoptosis. Practically all mycotoxins are involved. Then we're talking about transcription factors and gene expression regulation, where mycotoxins are involved. And finally, maintain disturbances of redox balance in the gut and redox balance in cells are considered as a major consequences of mycotoxin toxicity. So as a result, we have immunosuppression, hepatotoxicity, nephrotoxicity, neurotoxicity, genotoxicity. And in this case, we are talking about increased mortality, poor feed conversion ratio, poor growth rate, feed refusal, decreased fertility, and hatchability. More recent paper, 2018, confirms the same. This is a review paper, which again showing that aflatoxin, fumonisin, ochratoxin, zearalenone, DON, nivalenol, T2 toxin, they impose oxidative stress. They affect mitochondria, the major source of free radical production. They impose lipid peroxidation. They impose apoptosis, and they also affect or stimulate inflammatory response. Therefore, the pro-oxidant properties of mycotoxins are well established. And this most recent review, which came this year, actually showing that the major mycotoxins, including aflatoxin, ochratoxin, zearalenone, fumonisin, T2, HT2, and DON, they are produced by various fungus, and we are talking about Aspergillus, Penicillium, and Fusarium as three major genera involved in mycotoxin production. And you can see here in various food and feed materials, those mycotoxins can be found. And more specifically, if we look at the molecular mechanism of mycotoxin action, which was characterized in this most recent paper, you can see that the major research in poultry were done with broilers. Aflatoxin, ochratoxin, HT2, and T2 toxin were studied. And here you can see different doses of mycotoxins were used. As oxidative stress indications, the malonedaldehyde, final product of lipid peroxidation, was used, as well as the concentration of glutathione, major antioxidants, and total antioxidant potential. And what they showed very clearly that most antioxidant enzyme activity were decreased due to mycotoxin contamination. This means that the oxidative stress was imposed. If we look at the same paper on the pig side, again, you can see here DON, zearalenone, aflatoxin, fumonisin, They also were used in different doses. Similar oxidative stress parameters were studied, including MDA, glutathione, total antioxidant activity, and they were compromised. And most importantly, again, antioxidant activity or antioxidant enzyme activity were down, like catalase, superoxide dismutase, glutathione peroxidase. These are enzymes which are responsible for antioxidant protection, and decrease their activity is related to oxidative stress. And here is also interesting that pro-inflammatory cytokines are increased. And what about ruminants? Yes, look here, goats, sheep, lamb, cows. Again, the same mycotoxins were tested, various levels of mycotoxins. And similar to monogastric animals, again, malondialdehyde goes up, total antioxidant activity goes down, glutathione as a major cellular antioxidant goes down, and similar to previous studies, the antioxidant enzyme activities goes down. So what is the conclusion? The conclusion is that for all animal species, including poultry, pigs, and ruminant animals, mycotoxins are the problem. Mycotoxins imposed oxidative stress, and this oxidative stress is mainly related to disturbances of antioxidant enzyme activity. And this paper, which came 2018, is very interesting in a way. They look at the effect of mycotoxins on the mitochondria. As I mentioned, that mitochondria are a major source of free radical production. And if the mycotoxins can actually compromise function of mitochondria, more free radicals will be produced. And here again, you can see aflatoxin, DON, fulmonazine, ochratoxin, T2 toxin, zearalenone, and they actually were tested in various model systems, and it was very clearly showed mitochondrial dysfunction due to mycotoxin contamination. So this is one of the possible mechanisms of toxic effect of mycotoxins, affecting mitochondria. By affecting mitochondria, free radical production is increased, antioxidant defenses are compromised, and we are talking about oxidative stress. And most recent papers actually more and more attention paid to two transcription factors. These are specific factors which activate genes. So one transcription factor called NRF2, this transcription factor is responsible for synthesis or activation of synthesis more than 200 of different molecules. Most of them are antioxidants. And aflatoxin, DON, ochratoxin, zearalenone, they affect the expression of this transcription factor, and this effect is dose and exposure dependent. In the way that low doses and short exposure usually activate NRF2, which means at the beginning the body can try to protect itself from a toxic effect of mycotoxins, while higher doses and longer exposure inhibited NRF2 expression. And another transcription factor called NF-kappa B, and this factor is very important because it is responsive for synthesis of pro-inflammatory cytokines. And pro-inflammatory cytokines impose inflammation in the gut, in other tissues. And you can see here data on the effect of DON and other mycotoxins, zearalenone, on the expression of this NF-kappa B. Look at this paper in particular, it's 2010 paper, and what is shown here is that NF-kappa B expression increased almost 6 times. So in this case, DON can substantially increase the expression of this transcription factor. More pro-inflammatory cytokines are synthesized, and this explains why DON is so damaging on the gut. Now, effect of mycotoxins on NF-kappa B expression is condition dependent. Depending on type of mycotoxin, dose, duration of exposure, they can activate or inhibit NF-kappa B. And most importantly, there is a balance between these two transcription factors. And this balance is very much determined redox balance in the cell. Therefore, what are consequences of redox balance disturbances by mycotoxins? I mentioned already lipid and protein oxidation. By the way, more and more attention today is paid to protein oxidation, because lipid oxidation, that's something described many years ago. But in recent years, more attention is paid to protein oxidation as a major cause of negative effect of mycotoxins. Apoptosis, which is a programmed cell death, leaky gut and microbiota disturbances, immunosuppressions, damages to healthy tissues, including liver, decreased productive and reproductive performance. And this few papers just to confirm the negative effect of mycotoxins on apoptosis. So mycotoxins, including fumonisin, T2 toxin, and other fusarium mycotoxins, they easily impose a programmed cell death, which is called apoptosis. And here, one of the paper, and you can see here the T2 toxin increased the activity of caspase-2. This is a specific enzyme responsible for activation of apoptosis. You can see increase in 4 times, 8 times, 12 times. So the activation of apoptosis is very high. One more point, and again, one of the recent paper considering compromised intestinal barrier induced by mycotoxins. So mycotoxins can actually compromise microbiota in the gut, compromise chemical barrier, physical barrier, and immunological barrier in the gut. And that's why mycotoxins very often are associated with various diseases, because the protective effect of the gut is compromised. So when we're talking about healthy gut, we are talking about digestion and absorption, protective barrier, immunity, and balanced microbiota. You can see here normal villi, which are responsive for absorption of nutrients, and these are damaged villi, which could be due to mycotoxin. Do not expect good absorption and good feed conversion ratio in this case. So free radicals in the gut produced by mitochondria, phagocytes, and various enzymes. And today the actual topic, redox balance in the gut, is a very fashionable one. You can see plenty of reviews in a recent couple of years. And redox balance in microbiota, another topic helping to explain how mycotoxin can affect their health. In particular, mycotoxin can compromise microbiota. And in general terms, if we look here, the syndrome of malabsorption, that's something which is considered to be a common for aflatoxicosis, T2 toxicosis, ochratoxicosis, and this is a syndrome of malabsorption is a result of damages to the gut. So what we have here, we have mycotoxins in the feed, stimulation of lipid and protein oxidation in intestine, oxidative stress and damages to enterocytes, nutrient absorption decrease, antioxidant system is compromised. At the same time, mycotoxins are absorbed, delivered to target tissues and metabolized, and oxidative stress is imposed. So we have detrimental consequences for health. And generally speaking, antioxidants actually can help to deal with these problems. And they can help with gut protection, with liver protection, and immunity maintenance. Therefore, the whole idea is that first part of my presentation proves the point that mycotoxins in the diet can actually impose oxidative stress, which means there is a disbalance between free radical production and antioxidant defenses. On one side, mycotoxins increase free radical production, for example, by damaging mitochondria. On the other side, they decrease antioxidant defenses due to decreased activity of antioxidant enzymes. And this is related to few transcription factors, including NRF2, which is responsive for synthesis more than 200 of different antioxidants, and NF-kappa B, the specific transcription factor responsible for inflammation. And let's now, on the second part of presentation, let's look at nutritional antioxidants and protective strategy against mycotoxins. We need to remember that mycotoxins are very damaging. Even if you use some mycotoxin binders, you will never be able to bind 100% of mycotoxins. Those which are escaping binding, they are coming to the liver to be detoxified. And the detoxification in the liver causing oxidative stress and damages to the liver. So we need liver protection. On the other side, DON is detoxified in the gut, and gut microbiota also can be damaged due to mycotoxin contamination, and we need to maintain healthy gut. So when we're talking about antioxidant protection, we need to remember that all antioxidants in the body are working together as a team. We call vitamin E headquarters of antioxidant defense. Carotenoids communicate in services of antioxidant defense. Flavonoids and polyphenolic antioxidant police. We are talking about vitamin C and special forces. Selenium, chief executive antioxidant defense. And here we are talking about Ministry of Defense, which is gene expression and synthesis of various antioxidant enzymes. So when we're talking about nutritional modulation of antioxidant system, we can consider selenium, vitamin E, vitamin C, polyphenolics, and other nutrients which actually can affect antioxidant systems. And by improving antioxidant defenses, they can help to deal with mycotoxin contamination. So I will start from selenium, because it's my favorite subject, and I have been working with selenium for the last 20 years. Today, we know that selenium is a part of 25 selenoproteins. Those selenoproteins are synthesized in the body in response to stress. And at this slide, you can clearly see that more than half from those 25 selenoproteins are involved in the antioxidant defense and signaling. And now we are talking about dietary selenium, which can affect antioxidant defenses. It's our review 2019. And in this case, we are talking about breeder, egg, embryo, day-old chick, postnatal chicks. They are protected due to dietary selenium supplementation. If we look at the balance between NF-kappa B and NRF2 in the gut, you can see that mycotoxins, pathogens, and various stresses can impose oxidative stress and dysbiosis. And in this case, NF-kappa B and NRF2 can be affected. In this case, you can see the NF-kappa B is increased, so the synthesis of pro-inflammatory cytokines is increased, and the NRF2 is decreased, which means that antioxidant defenses are decreased. So if we look further, we will be looking at inflammation, apoptosis, immunosuppression, gut structure damages. Now, what's happened if we have optimal selenium status? So optimal selenium status will help selenoprotein expression. So there will be 25 selenoproteins synthesized. Then we have redox balance regulation, improvement of antioxidant protection. And this antioxidant protection will affect or prevent this oxidative stress imposed by mycotoxins. Then we have effect on prevention of activation of NF-kappa B, which means prevention of inflammation and improvement of antioxidant defenses. And we also have maintenance of commensal microbiota. As a result, we have activation of NRF2, activation of beta genes, and decrease activity on F-kappa B. And finally, maintaining redox balance, gut structure, immunocompetence, and gut health. So here, this selenium is taken as just as an example. So in general terms, the antioxidants in the gut can help to maintain these transcription factors in optimal activity, can help to maintain integrity of the gut, and this will help with first antioxidant defenses, and secondly, prevent the actually penetration of pathogens through the gut. And here, the review of 2018, and using this review, we can show how the system works. So we have oxidative stress imposed by mycotoxins. The disruption of epithelial barrier is taking place. Bacteria penetrate this barrier. As a result, the dendritic cells and macrophages will be activated. Macrophages started to produce reactive oxygen species, which free radicals, and they disturb redox balance. As a result, you can see mitochondrial dysfunction, which means that free radical production will be increased even more. And what we have, finally, we have leaky gut. Leaky gut means that the barrier is disrupted and the situation is very difficult. And in this case, we can talk, for example, about syndrome of malabsorption. So on the right side, look what selenium can do. Selenium can affect the prostaglandin synthesis and activation of various transcription factors, which actually prevent activation of this NF-kappa B, which is responsive for inflammation. So the pro-inflammatory cytokines goes down, anti-inflammatory goes up. We are talking about additional synthesis of selenoproteins. We are talking about additional synthesis of antioxidant enzymes like superoxide dismutase and catalase. And what is happening here? We are talking about redox balance reestablishment and inflammation resolution. So this means that inflammation is taken under the control. And in this case, we are talking about maintenance of the gut structure and antioxidant defenses in the gut will keep healthy gut and prevent those damages caused by mycotoxins. So now, when we're talking about selenium, we need to remember that there are different sources of selenium, and there is an inorganic selenium, which is its first generation of supplements, which came in many years ago. And in this case, this sodium selenite is used in many commercial premises, but the efficiency is low. Second generation of supplement includes seleno yeast and pure selenomethionine, and they have some problems like selenomethionine proportion in seleno yeast only 60–70%, and we have also some problem with stability issues, pure selenomethionine. So finally, the third generation of supplements came on the market, which is hydroxyselenomethionine, helping solving selenium problems and helping to maintain optimal antioxidant defenses, and this can help with mycotoxins. Okay, that was a selenium. However, the most important antioxidant and most studied antioxidant in biological systems is vitamin E. So vitamin E is an antioxidant which is located in cellular membranes, and vitamin E is preventing damages to those membranes. And if you can look at our review 2019, you can see that vitamin E has protective effect for breeders and cockerels, for semen, for egg yolk, for embryo, and for newly hatched chick. And you can see here, vitamin E increase antioxidant defenses not only by increasing vitamin E itself, but also by activating superoxide dismutase, glutathione peroxidase catalase. You remember from my previous slide that this enzyme activity was actually decreased due to mycotoxin contamination. So in this case, by using vitamin E, we can reestablish antioxidant defenses in stress conditions. Do we have any evidence related to mycotoxins? Yes. If you look at this publication 2008, it's an effect of T2 toxin and DON on DNA damages. So you can see here, DON and T2 toxin impose DNA damages, and by adding vitamin E, you can decrease those damages. And if we look more specifically in the review paper 2018, which actually look at the protective effect of vitamin E against mycotoxins, we are talking about aflatoxin, DON, fumonisin, ochratoxin, T2 toxin, zearalenone. In all those cases, vitamin E has a protective effect. Again, protecting against oxidative stress, protective against membrane damages, against actually disactivation of antioxidant enzymes. What about vitamin C, another antioxidant? Again, you can see in the same reviews, they showed that aflatoxin, DON, ochratoxin, T2 toxin, and zearalenone, they also their negative consequences also can be mitigated by using vitamin C. And again, you can see increase in glutathione concentration, glutathione peroxidase and superoxide dismutase activity, those enzymes which are inactivated by mycotoxins, decreased MDA level, which means decreased lipid peroxidation. And again, in previous slides, you saw that mycotoxins actually negatively affect lipid peroxidation, increase lipid peroxidation, and vitamin C can help you. And finally, the most exciting part, it's polyphenolics. The polyphenolics, there are more than 8,000 compounds in nature. You can see there are flavonoids, flavonols, flavonones, proanthocyanins, and other group of these compounds. And in general terms, polyphenolics received a lot of attention in the last 20 years, and they were considered as important antioxidants. And more and more data accumulated that the action of these polyphenolics is related to those transcription factors I mentioned already. So do we have any evidence that they have protective effect in mycotoxicosis? So if you look at this big study, which is 2019, and you can see here that the activity of catalase, glutathione peroxidase, and superoxide dismutase in duodenum, in the gut, was compromised. You can see a significant decrease. And by adding grapeseed extract, which is a source of polyphenolics, this was reestablished, which means that by using polyphenolics, we can maintain antioxidant defenses in duodenum. The same is true for the liver. You can see here, again, in the liver, the protective effect of polyphenolics is obvious. Another paper, 2019, the effect of polyphenols and vitamin E on antioxidant status and meat quality of broiler chickens fed naturally contaminated with ochratoxin A. Again, you can see here the same parameters, antioxidant enzymes, total antioxidant potential in the blood, in the liver, in breast muscles. And again, ochratoxin compromise those parameters, and polyphenolics and vitamin E actually having protective effect. And in some cases, the protective effect can be in combination even higher than in individual antioxidants. This means that by using these polyphenolics in the diet of chickens, it's possible to maintain antioxidant defenses in the gut. It's the place where actually damage is most important, as I showed you previous slide, for example, leaky gut. At the same time, the gut is responsive for detoxification, and again, to maintain gut integrity, to maintain the microbiota. It's a very important task, and these kind of compounds, dietary compounds, can help. And finally, one more compound called silimarine, which is a plant extract which is used more than 2,000 years in human medicine. And this is our big review, 2015, which actually described antioxidant properties of silimarine. And silimarine is very popular in a way showing antioxidant protection. And in the same at the same time, you can see here that silimarine actually affect the toxicity of aflatoxin. So you can see here the aflatoxin were used in chickens, and you can see body weight, day 28 and day 35. You can see significant decrease, and by using silimarine, it was recovered. The same is true for feed conversion ratio. Again, you can see control group, aflatoxin B contaminated group, and protective effect of silimarine. And again, silimarine is the most effective compound to maintain antioxidant protection in the gut, to activate transcription factor NRF2, which is responsible for synthesis of antioxidants enzyme, and downregulating NF-kappa B, a transcription factor responsible for the inflammation. One more paper, again, quite recent one, aflatoxin and Peking ducklings affect treatments with lycopene and silimarine. You can see the protective effect. And finally, what about other botanicals? I came to the end. Yes, the other botanicals can also help to maintain antioxidants defenses, including rosemary, boldo, and others. And one more point, probably the last one, BHT. BHT is commonly used as a feed additive to deal with lipid peroxidation. And in this case, the BHT can also help to deal with mycotoxins. So conclusions. Mycotoxins are major nutritional stress factors in poultry production. T2 toxin, DON, zearalenone, ochratoxin, aflatoxin, and fumamizine can impose oxidative stress. Oxidative stress is major mechanism of mycotoxin action. And as a result of oxidative stress, we have gut integrity damages, gut microbiota damages, immune system damages, and various organs can be damaged as well. This could lead to decreased productive and reproductive performance. And what antioxidants can do? Dietary antioxidants can help to maintain antioxidant protection in the gut, antioxidant protection in the tissues, and dietary supplementation of dietary antioxidant like selenium, some photogenics or botanicals can help to maintain antioxidant protection and can help to deal with mycotoxin toxicity. And that's my last slide, and I thank you very much for your attention.
Thank you very much, Peter. It was very exciting, very interesting presentation. Personally, I also learned a lot, and I would like to follow up certain things. We have several questions. And the first one is that what is the mycotoxin of most concern regarding oxidative stress?
In general terms, when we're talking about oxidative stress, the mycotoxins, practically all mycotoxins impose oxidative stress. The most dangerous one is T2 toxin, the most toxic one at the level of oxidative stress, ochratoxin, DON, zearalenone, and aflatoxin. These toxins are major concern of poultry, pig, and dairy industry, and this exactly mycotoxin impose oxidative stress. And that's why the general point of my presentation was to show you that all these mycotoxins can impose oxidative stress, I did not talk about combination of mycotoxins because I did not have enough time to explain, but the combination of mycotoxin can give even more important negative impact on antioxidant defenses.
And yeah, I just would like to follow up this question with my question regarding the levels of mycotoxins. That, for instance, European community accepts quite low levels compared to other countries for mycotoxins like T2, for instance. Do you think that oxidative stress can be also caused by levels which are below a limit allowed in feed?
Yeah, the problem is that mycotoxins never come singly. So if you have any feed, you would not, if you found, for example, aflatoxin, it does not mean that the feed does not contain T2 toxin or DON and so on and so forth. So in most of feed, there is a range of mycotoxin, and the combination of mycotoxin is more toxic than the individual mycotoxins. And therefore, the level of mycotoxins, which would be even lower of the legal limit in combination, can still have detrimental effect on the redox balance in the cell, on the antioxidant system, on those transcription factors I mentioned, and they can actually have detrimental effect first on the gut, and secondly on the liver, and if we're talking about ochratoxin, it will be kidney. So what we are talking about the independently of the level we have, we need to remember that this is a problem and we need to find a solution for solving this problem.
Thank you.
And may I ask, the next question is also about the species. Are ruminants equally affected as swine and poultry regarding oxidative stress? Any difference between species?
Well, I would say that with monogastric, it's much easier to study because the problem is that the ruminant bacteria can affect mycotoxins themselves. However, as I showed you with this picture from the last review, there was a proof that yes, mycotoxins also have detrimental effect on antioxidant system in cows, in calves, in goats, in ruminants in general. Therefore, what I would say that mycotoxins are also toxic for ruminants. However, as a scientist, I would say it's much more difficult to study mycotoxins in ruminants, especially how we would use, for example, different antioxidants in the diet to deal with those mycotoxins, because rumen sometimes can actually destroy antioxidants. For example, if we use sodium selenite as an example, okay? Sodium selenite is not coming through the rumen, it's precipitated there. Therefore, when we're talking about rumen, we need to pay more attention and the form of antioxidants we use and how long we use, what doses we use. But generally, the idea is still the same.
Thank you.
Another question is, what should we test in animals to see their antioxidative status?
Well, that's a difficult one, because you see, when we look at the antioxidant status which is used in human medicine, it's very simple. There is enzymatic activities, and there is a range of activities which are considered physiological, okay? So you have a table, you open the table, say, hey, this activity is lower than this data, and this means that the activity is low, it could be oxidative stress. At the same time, malondialdehyde as a final product of lipid peroxidation, most commonly used. However, the sensitivity of this test is not very high. Specificity is also not very high. It's easy to use, but information which you have is not good enough. Therefore, the most likely scenario, you need to use several tests simultaneously. There is no simple test, the one which can give you the whole answer. For example, the total antioxidant potential, it's a very good one. You need only 20 microliter of blood. You put in the tube, in 5 minutes, you have a result. However, if you look at the total antioxidant potential, if it goes down, it's bad, but you are not answering the question which antioxidants are involved. Then you need to look at the antioxidant activity. like antioxidant enzyme activity, superoxidismutase, glutathione peroxidase, catalase. And again, the major problem is for poultry and pig and ruminants, there are no stabilized data or data in table which are accepted by everybody. Therefore, what you need to do to look at the normal animals, which are without contamination of the mycotoxins, for example, and your experimental animals contaminated. If you see that in experimental animals, the activity on antioxidant enzymes goes down, lipid peroxidation goes up, this would give you the indications that oxidative stress is taking place.
Just related to that question, is there any difference between species in terms of checking the antioxidant status or the parameters to be checked? Or you can take blood of ruminant, swine, and poultry, and you can check the same type of compounds?
Yeah, you can check the same type of compound. However, the data which would be related to physiological level, you have to establish yourself for every species. And this, more importantly, those data will depend on the diet, will depend on the age, will depend on other stresses. Because when we're talking about mycotoxin stress, I did not mention my presentation, but you should remember that at the same time, there are environmental stresses like heat stress. There are ammonia, for example, in chicken house, which is also stress. So in this case, when we're talking about nutritional stress, yes, mycotoxins are major nutritional stress, but they are not working, separately. They are in combination with environmental stresses, with technological stresses, vaccination, for example. So those stress, which is a post-vaccinal stress, is a common stress. Therefore, those stresses are working together. And when you have a combination of stresses plus combination of mycotoxins, so every time you have a different situation, and you have to establish, for example, at the lab, whatever the lab is at the at the big pig farm, for example, they can take a blood from piglets, they can take blood from sows, they can take blood from boars and analyze, for example, for total antioxidant potential. There is no problem. The assay will be still the same. However, what is a norm, what is a pathology, you have to establish.
Okay.
Thank you. Next questions are about the antioxidants. With a limited amount of money to spend on the diet, what nutritional strategy, selenium or vitamin E or C, would choose to be, or anything else would be chosen to be most effective against free radicals?
Well, first of all, we need to realize that, for example, the diet is usually supplemented with premix, and premix contain vitamin E. For example, if we look at the vitamin E level in the premix for breeders, it will be 100 ppm. If we look at the growing chicken, it will be around from 30 to 50 ppm. If we look at the piglet diet, 100 ppm can do the job as well. So if everything is right, I mean the diet right, the premix is right, is that 100 ppm is sufficient to deal with oxidative stress? In most cases, yes, but when you have high mycotoxin contamination, you might go from 100 to 150. Then we look at the selenium study. Selenium is also part of premixes, and most of premixes selenium is supplemented at the level 0.3 ppm. The question is 0.3 ppm is optimal one? Well, there is no answer for that one, because the 0.3 ppm in most countries is a legal limit. You cannot give more legally. And this means that as a nutritionist, you are restricted how much and what you can add. However, if you look at the botanicals, there are no limit what you can use on them. But at the same time, you need to decide how effective they will be. Because as I mentioned to you, all antioxidants are working together as a team. Now you have to understand who is doing what in this team, and is it increasing the activity of selenoproteins is enough to deal with everything? No. The question is, the nutritionist has to design an optimal diet, taking into account all available information about stresses, about the level of mycotoxins, for example, in the diet, about the weather, for example, is a heat stress outside and the ventilation system is not able to deal with that heat stress. Therefore, the nutritionist has to decide what to do. There is no limit for vitamin E. You can go up, but it's an expensive pleasure. As for vitamin C, well, vitamin C is not a part of premixes because vitamin C is synthesized in most animals. And that's why the additional level of vitamin C usually added in specific anti-stress premixes, like in heat stress or maybe with mycotoxin stress. Again, vitamin C is good on one side, but vitamin C, when it's reacting with iron, for example, it's actually reduce iron from iron 3 to iron 2 and impose oxidative stress. So the situation is not straightforward. It clearly needs more research to understand how you will combine all those antioxidants to have the maximum protection in stress conditions.
Mm-hmm. And the question very close. Is it mixed of antioxidant or botanicals are more effective than single?
Well, again, there is no simple answer on that one. Because when you mix, it does not mean automatically that if you can 1 + 1 + 1, is it 3, is it 4, or is it 2? That's the question. Because, for example, when you're working with botanicals, you need to be very careful because botanicals, they have plenty of those polyphenolics, okay? As I mentioned, there are more than 8,000 different compounds. We know not much about them. We look at like quercetin or some other single compounds which are most studied, but we don't know about others. And we are not controlling others. That's the problem is because we can control the total amount of polyphenolics, yes. You can have the chemical analysis and say the total polyphenolics, this number. Is that number good enough for you? You don't know what are they. You know that, for example, maybe 2 or 3 of them, you might do the concentration chemically analyzing and you will see the concentration. What about others? There is no answer. Therefore, research should be done, or researchers should spend more time to understand how those botanicals works. For example, the absorption of there is very low, and they still can have a tremendous effect in the gut. Okay, if they are not absorbed, it does not mean they do not affect the gut, right? And they even it's sometimes good that they are not absorbed because they are moving in the large intestine, because the most antioxidants are absorbed in the small intestine, like vitamin E, for example. So vitamin E is absorbed in the small intestine and not coming to the large intestine. While polyphenolics, they are not absorbed well, so they go through up to large intestine where the major microbiota reside. So the microbiota can be affected by those botanicals. And actually the relationship between botanicals and microbiota, that's the current topic of research, most exciting part of research. Because today microbiota is considered as a separate organ itself. Because in the body we have more microbial cells than cells of the body itself. So we are talking about trillion microbials living there. And in this case, those microbial can do good job, bad job. And this job will depend on dietary supplementation as well.
Thanks a lot, Peter.
The question is about the species. What are the most sensitive animals to oxidative stress?
Well, with oxidative stress, of course, the most sensitive will be early live animals. For example, newly hatched chick, the chick during first week of the development. If you look at the piglet, newly born piglet, or piglet just weaned. So the weaning for piglet, it's a very high stress already. Okay, you should realize that when we have piglet, let's say for 4 weeks on milk, so the digestive system of piglet is adapted to the milk consumption. And suddenly on day 28, no more milk, dry feed, this is a very, very high stress. And in this case, the digestive system very often compromised, and there is a diarrhea and many other problems appear. So if you have oxidative stress at the same time, because the body is in compromised position already, if you add stress like mycotoxins or heat stress or any other stress, the sensitivity or consequences will be much higher. If you look at the breeder side, okay, we can say they are more resistant, but remember that there is a science called maternal programming, which means that how you affect breeders will have consequences later on. For example, if we look at the human side, we could say that few weeks of women pregnancy determine the health of future baby until end of the life. So which means the baby born, and then in 70 years later, there will be still consequences what mother was consumed. The same is true for piglet, for sow, for example, okay? We give, for example, oxidized fat for sow, okay? We might not see immediate effect. However, those changes at the gene expression level, and gene expression means that some genes can be switch on, switch off, and we don't know if those genes which are off will be on later on. Therefore, when we're talking about breeder diet or sow diet or cow diet, pregnant cow diet, we need to remember that we need to do maximum to prevent any stress at this period of time. Otherwise, you will solve one problem, like including antibiotics, for example, okay? You include antibiotics, you solve the problem of microbial contamination, but you affect those genes I mentioned already, and you can have consequences in terms of, for example, milk production of future cow.
I think we are running out of time. We have several questions, but also several comments I would like to address to you, Peter. So there is a personal message to you that it's a great job. Very well done. So from the participants. And there is also one comment that it's a miracle that we are still alive because so much stress.
Yeah, so we are alive because we have good diet and good sense of humor.
Yeah, exactly. So we will follow up other questions. We still have several, and we contact participants with email. And,
okay, I will be happy to answer those.
Thank you very, very much, Peter.
Okay, thank you. Thank you. It was a pleasure. Thank you.
Thank you. Bye-bye.
Thank you very much. Thank you. Bye. Bye. Bye.